So like I said in the last video, we like using the fundamental theorem of calculus to evaluate the areas underneath curves. But there are times when we don't care about the graph, we don't care about the area, we just want to know what an antiderivative value is. So, there are times when we're interested in definite integrals just for the heck of it, just for the sake of having a definite integral. Now, all of these problems can be somehow translated into a curve and into an xy plane with a function. So like, for example, this one can be drawn if you want. You can draw the curve, which is x squared plus 4. And then since I have the numbers 1 and 3 on the x-axis, that means I'm looking for the area between 1 and 3. So I'm looking for all this. But we don't really have to have a graph associated with these problems to be able to do the problems. We can always work out the antiderivative without having to have the graph in front of us. And that's what we're going to be doing in most of these problems. We don't care about the actual meaning of the antiderivative. We just want to be able to evaluate it. The word evaluate just means find the number. How much is it equal to? So when you hear the word evaluate, it should mean that we're looking for a number at the end. So let's go ahead and start with this first one. It says 1, 3, and then x squared plus 4. So the antiderivative going from 1 to 3 of x squared plus 4 dx. And the way it works is we start by doing the antiderivative for x squared, which is x cubed over 3. We add 1 to the power and divide by the same number. That's because of the power rule. And then again, for 4, we do the antiderivative because the antiderivative for 4 is 4x. And so we're basically finished. Normally we write down the plus c here, but we're not going to write down the plus c because we are dealing with a definite integral. Instead, we're going to put a low line and then put 1 and 3. Okay, here's what I did. I've done like a couple steps that I skipped. I used to do this in steps. Before, when I saw x squared plus 4 dx, I used to go, okay, let's write down the x squared into its own little integral, write down the 4 into its own little integral. Then let's take out the numbers, so we take out the 4 from the antiderivative, we get 4, empty space, and then dx. This is what I used to do before. I'm not doing that anymore. I'm just kind of mentally doing it. And that's when I get x cubed over 3 plus the 4x. I'm just doing these steps mentally, and I'm just recording the answer on the paper. That way I can save a little bit of time. Now, once you do that, what are you expected to do next? Well, you are expected to plug in the upper bound, then the lower bound. So the lower bound is 1, and the upper bound is 3. So you're going to start with the upper bound and plug it into all the x's that you're seeing. So we're going to go 3 cubed divided by 3 plus 4 multiplied by 3. And I always like to put brackets around them to remind myself that these two numbers that I got right here came from plugging in the upper bound into all the x's. Then I do the same thing again with the minus in the middle for the lower bound. So the lower bound is going to be a 1. So we're going to put 1 to the power of 3 over 3 minus 4 times a 1. Okay. Then again, where did I get all those numbers from? I got them from the fact that the lower bound is 1, and I plug in the 1 into the expression, the x cubed and the 4x. So that's where I'm getting the numbers from. And we're supposed to subtract because that's what the rule basically tells us to do. It says you subtract the upper bound antiderivative minus the lower bound antiderivative. Once you get this, you're not going to waste your time doing fractions by hand. You're just going to punch the whole thing into a calculator and get a number from the calculator screen. And then that's it. You're basically finished. So let's plug it into the calculator and see what happens. Turns out that the answer is 50 over 3. So let me show you how we can put this in a calculator in case you forgot from the last section. I'm going to go ahead and type all this into my TI calculator and hit enter. So I'm going to plug all of this problem into the calculator. If you remember, then go ahead and do it right now and pause the video and see if you can recall from memory. If you don't remember, just keep playing the video and I'll show you what it looks like when you plug it in. So there are two options on the calculator. The basic option is to use the math command and then find the option number 9, which is FNIT. This is function integration basically. So I'm gonna go down to number 9 and then select that one by clicking enter. And then typing in the equation or the expression that we have in the problem. In this case, the expression was x squared plus 4. Now I gotta tell the calculator that my variable is x. So it's kind of silly, but you have to do that. You have to put comma x because that's the variable I used at the front. Then I have to put the lower bound and then the upper bound. In this case, the lower bound is 1, the upper bound is 3. So when I do that and hit enter, it says a bunch of decimals. I don't like decimals, so I'm gonna click math 1 to turn it all into a nice looking fraction. And that's the 50/3 that I showed you on the paper. So this is one option. This is the fast option. Now, if you don't like this option, you can have another option where you go right here to the y and you graph the x to the power of 2 plus 4. Once you do that, click on zoom 6 to get a nice looking graph. Now, click second, trace, and that will put you in this calculate menu. Select option number 7. So I'm going to click up once to go to option number 7 quickly. And it's going to ask me what's the lower limit. In other terms, what's the lower bound? The lower bound is 1. So I'm going to click 1 and then hit enter. Then it says what's the upper limit. So where do you want me to stop? Where is the upper bound? So I'm going to select 3 for this problem and then hit enter. The calculator automatically highlights the region that we're looking for, and you can see the whole region is above the x-axis, and then it will tell you the answer is 16.66 and so on and so forth. Now, there's no way to turn this into a fraction on the screen. That's why I don't like this option so much. I prefer the other option. But both of them get the job done. Some of you guys have the fancy TI calculators, and if you have one of those newer fancy TI calculators, they're super user-friendly. When you click math and then select option number 9, it puts an integral with the d and everything on your screen. So this is like very simple. You just put in the numbers like you see them on the paper. 1, 3, then x to the power of 2 plus 4. Then you gotta integrate with respect to x. So you gotta tell the calculator again, my letter is x. Then you click again, it says 16.6. And then you go math 1 to turn it into a fraction, again 50/3. So regardless of how your calculator gets the job done, I wanna see the fraction at the end. So that's the answer that I'm looking for in these problems, the fraction.